Okay, guys, uh, the next section in part of dynamic in chapter uh, 6, 7, 5, 6, and 7, it's about equilibrium conditions. What is equilibrium conditions? That's mean is equilibrium means is if object moves, it moves by constant velocity. That mean is there is no acceleration. So equilibrium means is total force on all axes is zero. So in reality, we can say equilibrium means is acceleration is zero. Let me see why I did write like that. So acceleration is zero. If acceleration becomes zero, therefore we can say what? Total force on object is zero. Correct? So what is the equilibrium conditions? Remember, this is very important topic. We will see it as in next semester, hopefully in Physics 4B, starts from chapter 21, goes to the end of chapter 32. We will use this section, especially in Physics 4B. So equilibrium conditions means is total forces on x-axis equals zero. So total forces on x-axis equals zero, and also total axis on y-axis is equal with zero. So whenever we see, if they ask object is in equilibrium, that means is we have to apply these two things. Number one, total force on x-axis is zero, total force on y-axis equals zero. Then we will solve it as a set to find what? Unknown. Finally here, we have to have find unknown. Okay? So let's do one problem. Let me give you one example about equilibrium conditions. Look, guys, you see, usually if you go not in California, but if you go to Nevada State or Connecticut or New York, you will see in the cross sections in the streets, the red lights here in California, they are connected on the pole, and then pole usually it's aluminum, and then this pole is connected to another pole. Then red light is usually installs on that poles. But if you go on some of other states in United States, you will see that red light usually hangs, is attached to the cables, okay, and then red light is hanged bit at the center, at the middle section of intersection. So that is one of the examples. So if we go on second page here, it says example below figure, an object with mass of 50 kilogram, so it is heavy, is attached to two strings. One string is this one string is this one. Find tension on string. So let me put this one here. So this is like ceiling, okay, and we have two strings. One is attached with the angle between ceiling and string one is 30 degree, and the second one is 60 degree. So what we need to do, very simple, guys. Remember, in dynamic you have to verify your coordinate system. So let's choose coordinate system as always, put it at the center. No, let me go with Where is that? Eraser. Oh, okay. Okay. So let's verify x-axis. So let's say this is our x-axis, and in the same time I need to choose y-axis, correct? So this is y-axis. Now, after we verified coordinate system x and y, now we need to verify all forces. So what we are going to have for forces, we go by blue color. Here what I see, this is of course this one is mg, correct? This one is tension force, correct? And this one is, oops, and this one is, okay, not okay. All right. So let's say this one is also, yeah. So this is T1, correct? And this one will be T2. Now, what we need to do, we need to apply sigma F on x-axis is 0, and also sigma F on y-axis is 0. And we will solve these as set. What I am going to have, we have to verify forces. We did it. So this is mg, correct? This is tension 1, this is tension 2, and what we see here, we see tension 1 makes angle and tension 2 also makes the angle. So guys, if this is 30 degree, by geometry we can say that this angle is also 30 degree, and if this is 60 degree, this angle also is what? 60 degree. Okay, let me erase this. Oh, not good. Okay, so this will be 30 degrees, correct? Come on. Okay, let's verify forces. I go to verify forces one by one for tension 1. So what I am going to have here, this will be T1 cosine at 30 degrees, correct? And in the same time, this will be T1, correct, sine at 30 degree, right? And let's verify also forces for T2. So let me, okay, I am writing T2 a little higher. So this is T2. Okay, now let's verify forces. I go with green color for this one. So this will be T2 cosine 60, and this will be what? T2 sine 60. Am I right? So guys, let me change the color. So let's see what is forces on x-axis. What I see here, remember, anything toward the right direction is positive, anything toward the left direction is negative, anything up is positive, and down is negative. So here I am going to have on x-axis, I do have only two forces, T1 cosine 30 and T2 cosine 60. So anything toward the right is positive. Remember, this is important example, will be T1 cosine 30 degrees minus T2 cosine 60 equals 0. So T1 cosine 30, which is red one, is toward the right, is positive. T2 cosine 60, this green one, it's toward the left, so will be minus. So this minus this, red one minus green one, correct? On y-axis, what I have? Can you tell me how many forces do we have on y-axis? 1, 2, or 3? It is 3 because you see two forces is on the top on y-axis and one is down. So green one, red one is on the top and this blue one mg is down. So it will be T1 sinus 30 degree, correct, plus T2 sinus 60, am I right, minus mg equals 0. Done. Now the rest of job is we have to do calculations. We have to do calculations. So cosine 30 should be 0.87. Now I am going to have 0.87 T1 equal cosine 60 same as sine 30, so will be 0.5 T2, correct? Now guys, here I can find T1. So if I do, or I can find T2 actually, or T1, doesn't matter. So let's find T2 here. T2 will be 0.87 divided by 0.5. 0.87 divided by 0.5, 1.74. Correct? So using this equation, we found T2 is 1.74 T1. Now I'm going to use this equation, substitute it here. Okay, so that will be 0.5 T1. Sine 30 is 0.5. Sine 60, 0.87 should be correct. Make sure, yeah. Plus 0.87 T2 equal mg, mass is 50 kilogram, so 50 times 9.8, it will give you 490. Yes. So here is one equation and here is second equation. So we have actually two equations with two unknown. So what we did here, we found T2, which is 1.74 T1. Now let's substitute T2 in this equation, okay? So I'm going to have 0.5 T1 plus 0.87 times 1.74 T1 equal with 490. Now, if you find for T1, solve it. Let's see what I have. I'm going to have 0.87 times 1.74, correct, plus 0.5, that's 2.01. So 490 divided 2.01 becomes 243. Maybe sometime I do wrong calculations. You do it again, please. And if I got T1 is 243, so 243 times 1.74, answer is T2 becomes equal with 423, let's say. Make sense? Let me organize this section. There you go. Okay, so we found T1 and also we found T2. Now you can check the answers, guys, with picture. Look, tension 1 is 243. Tension 2, it's 423. Okay, it's almost 200 newtons, something more, 180. So what do we see here? The string that has less angle, it's smaller than string. The tension is smaller than string that it has big angle. So another conclusion that we can say this: the string that has bigger angle, it has also bigger tension. Why? Look at the picture. I can tell you just without solving that tension 2, actually this string number 2, tolerates more force. It applies more force on mg. It applies more force, tension force, to hold mg than T1 because it's shorter. Remember that. So I actually got a premium video recorder, so I'm not worried about maximum time 15 minutes, so I can have unlimited video recorder time. So please work on this problem. I can tell you that almost I'm done with chapter 5, 6, and 7 in your book with dynamic. The only topic that it left, it's force of gravity, so that's the different thing. And then I will go on chapter 8, it's about circular motion, and then we're done completely with dynamic. So circular motion, it's also part of dynamic. So chapter 5, 6, 7, and 8. So you can start to work on the problems in chapter 5, 6, and 7, please. But I suggest you to work on chapter 6 and 7. These two chapters are very important. Okay, 6 and 7. Yes, please. So you have your syllabus. Please start to work on these problems, chapter 6 and 7. I don't need chapter 5. Chapter 5 is more introduction. And I will go over problems also, but I have to finish chapter 8, then all together I will continue the solving problems. So on this week I will finish completely chapter dynamic, so your exam will be very soon on next week. Okay, so we will talk. We're gonna have office hours hopefully on Monday by Zoom. I will invite you, so please go to Confer Zoom in the part of syllabus, in the part of Canvas, and then verify your username, your password, to not have any problem on communication day. Okay, I love you guys. Hope you have great Saturday evening and Sunday night, Sunday morning, all the Sunday, and blessed day. See you later. Bye.